Okay, in this video, I go over Chapter 9, Problems 8, 9, and 11. I also go over the Supreme Auto Parts problem where I provided the file. I'll do another video for the Boston Red Sox case study. So Problem 8 and 9, we are doing a center of gravity analysis. A center of gravity's purpose is to choose a new location that will serve these existing locations. So these are existing locations. This is the demand requirement that we need to ship to them. Where we ship from is what we need to decide, and you can use center of gravity to do that. The center of gravity method is the product of the coordinate multiplied times the volume over all segments, and then divide by the total volume to get a coordinate. So the optimal location that doesn't exist yet is at 7.6, 8.3, which is this big red one. When you initially build the graphs, when you initially build the graphs, they're all the same color, but if you just left click on this twice, then you can change the color of that. Problem 9, we're moving volume around. So it was originally like this. So this is the problem 8. This is problem 9 where the volume is shifted. So the volume has moved where we have less at segment 1, and it's moved to segment 2. So the total volume didn't change. So the circle sizes are still the same, but this is segment 1, and segment 2 is there. So we moved volume, you can see a big circle to a small circle to about the same size, and because of that, the center of location moves to the right. Problem 11, where we're doing this multi-factor rating, we're given 1, 2, 3, 4, 5 criteria. Someone has weighted these this way, and then based on those, then we've also evaluated each of these 4 locations where our scale is poor, okay, good, and very good. So this is the data given. So what we have to do, the first thing we have to do is convert these into numbers to some scale. And you could use any scale you want. It's ordinal data. So all ordinal means is that the ranking, we know what the ranking is. Very good is better than good, and good is better than okay, and okay is better than poor. So whatever numbers we turn into, as long as they are ranked, where this number is bigger than this one, and this is bigger than this, and this is bigger than this, it makes sense. But this might not be an actual, and so what I've done is try to we put a number, and all we're doing is that you could put whatever you want. And from these numbers, I need to convert these to numbers. And so what I used was a VLOOKUP to be able to quickly, and you didn't have to do this, but this is a way to quickly change these numbers. A VLOOKUP looks up a certain value in a table in the leftmost column. So what I'm going to do is look up G in this table that I grabbed, H2 through I5. I find G in the leftmost column, which is this column, and then it returns the corresponding row in the value from a column that's given here. So the third argument is the column index. So if that's column 1, column 2, finds G in column 1, always in column 1, and it returns, in this case, the 3 in column 2. The last argument is the range lookup, and true means find an approximate match. False means we need to find it exactly, and we do want to find it exactly. I want to find exactly G. So that's how these numbers came about from this. This is just a formula that I copied down everywhere. And now that I've got that, I can write a sum product formula, which takes this weighted average against these numbers, and whichever one has the highest rating is the location preferred. Whoops. I can't copy over until I put some dollar signs around column B. Now I can copy this to the right. And the higher the better. So in this case it looks like location 1 wins. I could change these ratings. What if I really wanted to reward very good into something bigger. And you can see it's still, this one came up more because it does have a 5 in it. But these numbers, so it's still number 1. And all you would want to do is evaluate these and see if these would ever change the preference while still remaining within this ordinal data. Okay, so this is the best one, location 1, based on this rating. The transportation problem, this is the data that was given. We are shipping from these places, so we ship here to here. So we're shipping from Amarillo to either Detroit or Atlanta, and we're shipping from Charlotte either to Detroit or Atlanta. This is the cost, so the cheapest thing to do is when it's close together. You can see Charlotte is really close to Atlanta, so the cost is the cheapest. Far away, Amarillo all the way to Detroit is the most expensive. So what we want to do is ship the cheapest way, but we're limited on just looking at transportation cost. We've got to look at our capacities, and we can't exceed that, and then we need to ship to the places that need more stuff, so that's what the demand are. And then the last thing, which is not in the lecture videos, is that anything that leaves Amarillo has to be made in Amarillo, and the production cost in Amarillo is much less than the cost in Charlotte. So how do we build a model to do this? What I do is I grab this data, copy it, bring it down, and then I'm going to turn all of these into non-dollar signs. I'm just going to turn them into a regular number. I may show 1 decimal. And these are going to be my unknowns. These is what I want the model to decide. So these cells represent what Excel will have control over, where this will represent the amount shipped from Amarillo to Detroit. I don't have to do what I'm doing now, but I'm going to just put in a different number so I know it's different. And then my total shipping cost or freight cost some product of these 4 numbers and these 4. But I also have a total production cost. And I could write a standalone formula. I could take the sum of these. This is everything made in Amarillo multiplied by the unit cost plus the stuff made in Charlotte. Excuse me. Stuff made in Charlotte multiplied by the unit cost in Charlotte. 2 cost drivers. Both of these I'm going to turn into dollar signs. And so my total cost are these 2. So what I want to do is decide what these numbers should be to minimize this, and then I can't exceed capacity. So the amount shipped, so I'm going to put that here. This is the shipped, which is going to be the sum of these. This has to be less than this. This has to be less than this. And then the amount that's shipped to Detroit are these 2 numbers. And this number needs to be greater than equal to this, and this has to be greater than equal to this. So I think that's everything in Excel I have to do. Now I need to go to Data Solver. And I want to set the objective of the total cost to minimize by changing these 4 cells. Then I'm going to add my constraints. The amount shipped has to be less than equal to my capacity. And notice I've actually written 2 constraints because it's a set of constraints. I grab 2 rows and I reference 2 rows over here. So my left hand side and my right hand side actually are representing 2 rows, 2 constraints written as a set. Not that important, but it does save you time on doing this. I'm also going to write 2 demand constraints. The amount that ships to these Detroit and Atlanta has to be greater than or equal to demand. And because everything that we're doing in this class is linear relationships. I'm going to use the simplex LP, and I've done this. I'm going to hit solve. Hit OK. It says it found a solution. When you see things like that, that just means that it doesn't fit in the cell. So you just make that cell wider, and it works. So you can see how what the answer is that Amarillo should serve Detroit, and Charlotte should serve both Detroit and Atlanta. So Atlanta has a single source of supply. Charlotte, Detroit is getting things from Amarillo and Charlotte. This is the total cost. You could certainly graph this if you wanted to see a breakdown, which I think is always important to put a graph together. So production costs are certainly the driver. It's the biggest part of this. And this is the shipping cost. So it looks like the biggest bang for your buck is probably to improve these, try to work on these. But everything helps, and this is there's certainly a logistics cost of $24,300 involved with this. We maxed out Amarillo. The amount that is made at Amarillo and shipped from that is maxed out. The amount made at Charlotte is less than the capacity of Charlotte. So if I wanted to add capacity, I would want to add it in Amarillo, not Charlotte. Okay, I'll do another video for the Red Sox case study. Thanks.